Welcome back to your learning journey in this statistics and probability for data science. And my name is Moot, and this is our continuation in our learning journey of the statistics and probability for this data science. Now, as we proceed in this video, we are going to understand about the inferential statistics, the concept of population and sample, and what are the various types of inferential statistics. So let's get started. Let's start by understanding what exactly is this inferential statistics. When I talk about this inferential statistics, it's a branch of statistics which makes the use of various analytical tools to draw the inferences about my population data from the given sample data. Remember this, we use this inferential statistics to draw the inference about the population from the sample data. So these two terms, that is population and sample, are very much important, and it's very important to understand the difference between this population sample. So in your previous learning journey, you have understood what exactly is it descriptive statistics. So if I talk about this descriptive statistics, you have learned that we use it to generate the summary of the data set. Now, I have mentioned that we use this inferential statistics to make the inferences and the prediction about the population based on the sample. So I hope you understand the difference in the definition. Now that you have understood the difference in the definition of descriptive and the inferential statistics, now let's understand what does it mean by a population and what does it mean by a sample. Now here, when I say population, a population is the entire group that you want to draw the conclusions about. And when I say sample, a sample is a specific group from this population. It's a specific group from this population that you are going to collect the data from. So that's the major difference between the population and the sample. Now, to understand the difference between this population and sample and why do we actually do this, let's take up a case study. Now, you have been given with the case study. The case study is you are given to predict the average data scientist salary in India. Now, that's the task that you're given with. Now, here, in order to perform this activity, obviously you are looking to predict the average data scientist salary in India. So, what is the data that you're looking out for? You are looking out for a data which is nothing but the entire list of data scientists who are present in India. So all the data scientists in India will be your population. And obviously, if you think about it, let's say there are close to 200,000 data scientists are available in India. It's just a random number. So what you have to do is, in order to predict this value, you have to call each and every person, or at least find a way to understand their salary. And once you have got the salary from each and every person who is present in the India who is working as a data scientist, divided by the number of people that you have got, so that you can get the average, that is the mean value. Now think about it. Is it really realistic? Just think about it. Is it possible to collect the data from 200k? So 200k people, is it possible? No, it's not possible, isn't it, guys? It's very difficult to call each and every person. And even if you try to complete it, think about the resources that you have to spend. Think about the time that you have to spend in order to collect all these details. So what you have decided is, okay, let me not go into collecting the data from each and every individual which is present, who is actually present in the entire country. So I'm going to select a specific city which will be a representative of my entire country. So you will say that, okay, I'm going to collect the data of the data scientist who is working in a specific city in the country India, that is in a Bangalore city. So what you have done is, in your entire population, this is the data scientist who is working in India. Now from this entire population, you have selected a sample where this sample is the data scientist salary working in a city called Bangalore. Okay, so what you have done is you have selected a sample from the population. Now, if you choose the city of Bangalore, let's say you have 5,000 people who is working in this field of data science. Okay, 5,000 people who is working in this field of data science in a Bangalore city. Now compare to the 200K, compare to the 200K, 5,000 is to collect the data, isn't it? At least it's easier for you to collect the data. It's easier for you to call up them or find a way to interact with them and get their salary details. Now, let's say you have met each and every person, that is each and every data scientist in Bangalore city, and found their salaries, and then you have divided by 5,000 to arrive at the average. Now, the average value that you have got is 12 lakhs annum. So this is the average value, that is the average salary of a data scientist that you have found for the Bangalore city. Now, what you are going to say is, okay, so 2 lakhs per annum is the average data science salary, that is the average data scientist salary for the data scientist working in India. So I'll repeat, this is very important. You have collected the data from the Bangalore city data scientist, and from there you got the average as lakhs, and this 12 lakhs, now you are saying that this will be applicable for the entire country, that is for the entire population. And this is what, yes, this is what an inferential statistic is. You are going to consider a sample, perform the analysis on this sample, and then whatever the output that you get, you are going to generalize it to the entire population. And that is the whole idea behind this inferential statistics. Are you with me? Perfect. So that's how simple it is, guys, when you talk about inferential statistics. Now, one key thing that you have to remember is selecting the sample from the population. In order to select the sample from the population, we've got various techniques. And here in statistics, we basically have two classification. So one is a probability sampling technique, and the other technique is called as non-probability sampling technique. Under this probability sampling, we've got simple random sampling technique, stratified random sampling technique, cluster sampling technique, and systematic sampling technique. So these are the various techniques that we have. That is the strategy that we use to select a sample from the population. And even in machine learning, you might have seen that we make use of train test split function to split the data into two parts, isn't it? One is a training set and the another one is a validation or a test set. And there, if you remember, we also have the option to randomly split the data. If you randomly split the data, it will be a simple random sampling. And if you use a parameter that's called as stratify, that will be a stratified random sampling. So these are the most commonly used sampling techniques. Now, apart from this probability sampling techniques, we also have non-probability based sampling techniques. So just remember it for your understanding. Okay, these are all non-probability based. There is one method that's called as snowball sampling, convenience sampling, we've got judgmental sampling, and the quota sampling. So these are the other techniques that we have got under non-probability sampling techniques. Now the question is, why do we analyze the data? That means, why do we analyze the data on a limited data, even though we've got the population available with us? Well, the reason that we prefer to work on sample compared to the population, because one, it's cost effective. The second one, it's efficient, it's practical, and given the representative of a population, if I have a good representative of the population in my sample, then even I can get a higher accuracy at very less time. So that is the reason that we prefer sample compared to the population. Now, when we talk about this inferential statistics, so this inferential statistics can be classified into hypothesis testing and the regression analysis. Here, when we say hypothesis testing, we will be using the confidence interval to test the parameters of a population. And when we say regression analysis, we will be using it to quantify how one variable will change with respect to the another variable. So this was about the introduction to inferential statistics. In this topic of inferential statistics, you need to understand the meaning of population, samples, the high level idea about the various types of sampling techniques, and you have also learned about the types of inferential statistics. Now with this, we come to the end of this video. Now, as we progress in our learning journey, in the next video, we will understand the various types of data which will enable us to select the data analysis technique as per the data that we are working with. All right. So thank you so much for watching, and I look forward to seeing you next time. So if you're new to our channel, please consider subscribing, and thanks again.